So now we're going to go through a couple different things. One is we're going to look at some examples. Got one behind me here. But before I get into the examples, I want to go through just a couple other features of the tangent function that I want to just clear up before we get into the examples. So one thing, just that just a reminder, the period is pi, and it runs from negative pi over 2 to pi over 2. So you essentially take the period, take half of it on the left side of the y-axis and half of it on the right side. Okay. The domain. So for the tangent function, every odd multiple of pi over 2 gives you a vertical asymptote. We saw that in the previous video. Pi over 2 or 3 pi over 2. If you kept going, it'd be 5 pi over 2, 7 pi over 2, and then on the negative side, the same thing. Okay, and so the domain is all real numbers except for at those vertical asymptotes because the function is undefined there. Okay, so you would say that the domain then is all values of x such that x is equal to, or x is not equal to, so it can't be equal to an odd multiple of pi over 2. How do we represent an odd multiple of pi over 2? Well, you take an odd number. Well, how do you represent an odd number? That's 2n plus 1 or 2n minus 1, however you want to write that. Either one is odd. So I'll say 2n plus 1 times pi over 2. So there's my expression. 2n plus 1 is an odd number times pi over 2. And in order to make that an odd number, the n has to be an integer. Okay, so where n is an integer. Okay, so that's all in the description. I didn't leave myself enough room to get it all in one line. But technically that should all be, running in one line. All this stuff is in the description or the characteristic of the set. Okay. The range then is going to be, well, the outputs from this graph, right? The outputs of a tangent could be, anything positive, this thing goes up indefinitely, anything negative, because it goes down indefinitely, and 0. So it's going to be all real numbers. There's no value that you cannot get out of a tangent. So the range then is going to be negative infinity to infinity. Okay, all real numbers. The X-intercepts are interesting. There's an X-intercept at every multiple of pi. So if you'll notice, it starts at 0 in the previous video. Your X-intercepts were at 0, pi, 2 pi, 3 pi, 4 pi, and so forth. And then again, the same in the negative direction. And then the asymptotes fell halfway in between at your halves. So the X-intercepts are all at x equals any multiple of pi. So I'll say n pi, where n is an integer. Okay, so your X-intercepts are any integer multiple of pi. And then of course the y-intercept, well, there can only be one, otherwise this wouldn't be a function. And that one y-intercept is at the origin 0, 0. Okay, so that's the point 0, 0. So that gives you kind of a breakdown of some of the other features of the tangent graph or tangent function. Okay, so now that we've kind of looked at that, let's take a look at an example. We'll look at the y equals 1/3 the tangent of 4x. This is going to have both an amplitude change and a period change, but we're going to consider our 5 key points based upon this idea where you take half the period on either side of the y-axis. Okay, so let's first take a look at that period. This is in the form y equals a tangent of bx. We've seen this sort of thing with the sine and cosine before. The a represents the amplitude, so to speak. Remember, amplitude is the height of the point halfway between the x-axis and the vertical asymptote. And the b value is how we found our period. The period for this would be pi over b. Okay, so the period, again, is going to be pi over b, which in our case is pi over 4. So that's the whole length of the period is pi over 4. Now if you consider taking half of that to the left and half of that to the right of the y-axis, you would have a pi over 8 on each half, or on each side, okay? So take half of pi over 4 on each side. Well, half of pi over 4 is pi over 8, right? You multiply those two things together. So you'd have negative pi over 8 is less than or equal to x, which is less than or equal to pi over 8. Okay, so pi over 8 to pi over 8, that gives you two consecutive vertical asymptotes like we have here. Okay, so I'm going to go ahead and start to plot this. So I've got negative pi over 8 as one of my vertical asymptotes, and on the other side, pi over 8 is the other vertical asymptote. And if I wanted to keep going, I would need to go another pi over 4 to the right. Well, it'd be, so you go pi over 8 on each side of this. Oops. So then, you know, you'd have the next spot would be, so this is 1 pi over 8, you have 2 pi over 8, which is pi over 4, would be another X-intercept, and then 3 pi over 8, which is another odd multiple of pi over 8, would be your next vertical asymptote. So just to give you an idea of what two periods would look like. Of course, you could map it out to the left, 2 periods, however that is you know, asked of you. So I'm still working with 1 period here. I was just kind of giving you an example of what would happen. I'm not going to go through and put all those details in. This will be good enough. So from negative pi over 8 to pi over 8, that gives us how much is on each side. Now, that total distance is our pi over 4. It's 2 pi over 8's added up. The halfway points then, or whatever half of pi over 8 is. Well, what's half of pi over 8? It's pi over 16, right? You double the bottom. So this one is negative pi over 16. This one is positive pi over 16. That gives us our two halfway points. Now the amplitude, remember the amplitude is the absolute value of this A value, which of course is 1/3, okay? So remember this 1/3 now is the value of the function halfway between the x-intercepts and the vertical asymptotes. Okay, so in our case, at negative pi over 16 and at pi over 16, the value of the graph, the height, is 1/3 or negative 1/3. Okay, so I'm going to go ahead and put 1 and negative 1 on the graph, and then cut those into thirds, just so I have a reasonable idea of what this looks like. And then we know that our tangent graph goes up to the right, down to the left. So at pi over 16, the graph will be 1/3 of a unit high. And at negative pi over 16, the graph will be at negative 1/3 of a unit high. Okay. Then we sketch our graph. Remember, it's going to start lower left and go kind of swerve up and to the right. So I like to start at the origin just to get the curve somewhat accurate here. It's going to be a bit wider there at 0, or flatter, because it has to hit 1/3 instead of going down to 1 or negative, or on the other side has to hit positive 1/3 rather than going up to positive 1. So yeah, so it's a little bit flatter there, but still has to hit those points. Okay, so that gives us a pretty good idea of what 1 period would be. Again, if I were to plot this out beyond 1 period, it would just be a repeated process, a repeated curve here in between two vertical asymptotes. Okay. Okay, so that pretty much gives us all the information we need for this one. In our next example, we'll take a look at some shifting going on as well.